Hello everyone, this is Kenneth Brenny from Cambridge Tech and welcome back to the channel. So if you are watching this video, this is the second part of a Pandas series, and in this video we are basically learning the Pandas library. So if you haven't watched the first video, I highly recommend you watch the first video because I cover a little more of the fundamentals of Pandas, and here we are extending on that knowledge that we have into other things. So over here we are going to look at how we use Pandas on data sets. So we are going to basically look at things from a number of perspectives. When it comes to working with data, there are some reliable sources where we get data from, and we can get data from Kaggle or the UCI machine learning repository, and you can also get data from experimental trials. So maybe you are working on some project and you generate your own data, you definitely would have some kind of data sets. Over here, we are going to look at the iris data set. Here are two links. It takes you to the link where you get the data set. So the first link I have over here is the iris data set from Kaggle. So when I click on this link, it sends me to Kaggle, and this is where we have the iris species data set. And you can see that it's originally from the UCI machine learning data repository and updated about 6 years ago. And you can also click on this link, and this one takes you directly to the UCI machine learning data repository. There's a bit of information over here, so you can see that the iris data sets you can download by just clicking on this, and we can look at some kind of descriptive things around the data set. And when I click on this, you can see that it will have this showing up over here. So when I click on this, it downloads the data sets for me. So this is just one way of going about it. But then whenever you have a data set, one of the things you should know is you need to familiarize yourself with the data. And that's essentially why we'll need Pandas in some capacity, because we'll be doing some exploratory analysis of the data set. But let me give you a gist of what this whole data set is about. So once upon a time, some researcher in 1936 decided to gather data on some species of flower, and this species of flower is what we have over here as the iris flower. So this particular flower has 3 categories, and the distinction between them has to do with the sizes of the petals and the sepals. So you can see that when you look at the iris setosa, the petals and the sepals are a little bit not too big as compared to vesicular and the iris virginica. So that's basically the distinctions between these 3 categories of the same type of flower. Good. Now, fortunately, with what you are doing, I have this data set already downloaded, and it is part of the repo. So you definitely have this over here, and that's what you have over here as the iris.csv. Now, this is a CSV file. So CSV stands for comma separated values, and we are going to see how this works. So having known that we have our data in here, we would want to import our data, and we are going to do so using Pandas. So let's say we have a variable called dataset. Now dataset is going to be equal to PD. Remember from the first video we had already imported Pandas as PD. So I can do pd.read_csv, and inside of a string I'll pass in the name of the data set. So it is iris.csv. Remember, that's the name we have over here, iris.csv. And you can see that Python is case sensitive, so the name should appear exactly how you have it in your file. So now when I do a shift enter, you can see that the cell has run. We don't seem to have any problem over here. Now bear in mind, one of the common mistakes we all do is sometimes we are so carried away we even forget to bring the .csv extension. Now when you do this, it is definitely going to catch some error, and at the very bottom it says no such file or directory iris. So whenever you see something like this and this is what you are doing, you should bear in mind that you probably are missing out the CSV extension or perhaps even the name. Okay, so even if I bring the CSV, and so what you have over here is not going to work. Good. Now even if I bring the CSV and the spelling of the name is wrong, so over here I have Irie, it is still going to tell me that I have no such file as iris.csv. So whenever you see this, you just have to go back and check the exact name. So that's very simple, and we'll do iris.csv. Good. So now we would want to view the data. We want to have some visualization of it. So what I'm going to do is I'm just going to print out data sets over here. So when I run this, here we are. So in this particular data we have, and there's a data frame. Okay, everything we have over here is saved in a data frame. So let me just print out the type, and let me just do data set over here, and you can see that it is of a type pandas.core.frame.dataframe. So everything we are covered using data frame in the first video applies over here. So here we are with the data set, and one of the interesting things we should know is the fact that these are the indexes. Okay, and here we have an ID column over here. We have the sepal length cm, that's like the sepal length in centimeters. We have the sepal width cm, we have the petal length cm, and the petal width cm, and this is the category of species based on these dimensions of the sepal length and the sepal width. This is what we have, and this particular data set is like the mother of most data set for some machine learning projects, and later on I'm going to release videos to that effect. So here we have, when we print out data, it is going to show the first 5 rows, and it's going to truncate this and show the last 5 rows. Like I said, we just want to have an overview of it. Imagine if the data set is like a million number of instances or rows. We don't expect to see everything. It's just going to show us, a preview. Now what you can see over here is the fact that it also shows us some information over here. So we have 150 rows. Remember, the rows are the horizontal cross section. So this row of index 0 is like the first row, this is the second row. So we have 150 of these, and we have 6 columns, and the columns are the vertical cross section. So we have this as column 1, which is ID. The sepal length cm is the second column over here. This is the third, fourth, fifth, and finally this is the 6th column over here. So this is what we have in our data set. Now there are some few methods I would want us to look at. So if you want to check the head, and the head method returns the first 5 rows of the data frame. So let's say if you have data sets, and if I'm to do a dot head like this and run this, this is going to return the first 5 rows. So as you can see, we have 0 to 4, and this with the index. So it starts counting from 0 and it ends as 4. We have first 5 rows showing up over here. Now if I'm to put out, let's say, a number inside of the parentheses as, let's say, 10, and run this, it is going to return the first 10 rows. I can go on to do, let's say, 20 to return the first 20 rows. I think this has a limit, because clearly if I put out something like 100, it is not going to return the first 100 rows. It's going to do exactly what it is supposed to do if the number of rows being returned is too large. But I think it will return the first 50 rows. If I put 50 over here, clearly we have the first 50 rows over here, and then that's index 49. And let me try and see if it will return the first 60 rows. Yes, the first 60 rows is also being returned over here. And let me also check if it will return the first 70 rows. Clearly at some point it will tell you that I can go beyond this. So give and take is between the first 60 to maybe 70 rows or 69 rows. Let me check 69 and run this. It doesn't return the first 69. Let's say 68. It doesn't. Let's do 61. It doesn't. So definitely the upper limit of returning everything is ending at the first 60 rows. All right, so there's a bit of new information I have for myself. So let's go back to the first 10 rows, and this we can see that everything is showing up very nice over here. Now the head is going to show us the first. So if you want to look at the last, then we will have to use the tail method. So over here I can do dataset.tail, and now when I run this, you can see that I'm counting from the last 5 rows over here, and the same principle applies over here. If I'm to put out 10 over here, I'm going to count from the last 10 rows of the data. Now we would want to also check the shape, which in some instances can be very interesting and very important. So when I do dataset.shape, and please, the shape is an attribute, so we don't pass in a parenthesis like this. So when I run this, you are going to see that we have 150,6, and the notes I have over here says, now the shape returns a tuple, so you can see that there's a tuple, obviously showing the number of rows and columns. So this is the number of rows and this is the number of columns. So how do I know there's a tuple? Now there's a tuple because it is wrapped up in this curved bracket over here, and if I'm to literally print out the data type of this, it shows that there's a tuple. So this is a very simple thing to understand. So let me come back here, and we see that it shows the number of rows by the number of columns. So this can be very important, because if you see some of these things right at the back of you just running these things, you begin to understand how big your data set is. Now you also have the info method over here, so it returns some basic information on the data frame. So if I'm to do dataset.info and call it up this way, you see that I have a little bit of information or descriptive analysis of my data set in here. So over here it says this is a pandas.core.frame.data frame. It is telling us exactly what we have for that particular data set object we have in here, and it says the index range, and we have 150 entries starting from 0 to 149. Now the data columns, the total number of columns is 6, as you can see over here, and these are the columns. So it lists all the columns by names over here, and their index is also showing up over here. Now it says non-null count. So what this basically means is, within the column ID, I have 150 non-null count over here. That means everything is filled up. Within the specimen length CM, I have 150 non-null count. That means everything is filled out. Now later on, you are going to see instances where we have some missing data, and this info is just going to show us where we are missing some data, and it can come in very handy. And you can see that you also have the data type showing up over here. Now one of the things you'll be dealing with when it comes to data is sometimes you need to do some pre-processing, and Pandas is going to help us do that. So we are going to use Pandas for data pre-processing and cleaning. So data cleaning means fixing errors or bad data in your data sets. This is a pre-processing activity that needs to be carried out even before using the data set for whichever reason you would want to use that particular data set. So bad data sets could be a combination of any of the following. So empty cells or null values. Then we can have data in wrong formats. We can have wrong data itself, and sometimes duplicates. So let's look at how we pre-process and clean data. And over here, once again, I have this iris_modified. So I took this original data set and I did some personal modification to it in order to get an instance where we are going to apply some of the techniques to clean up this particular data set. So in order to import this, once again, let's create a cell beneath this, and let me call this data. So data is now going to be equal to PD, which is our pandas dot read underscore CSV, and inside of this I have iris underscore modified dot CSV. So when I run this, yes, we don't seem to have any problem. Now when I print out my data, you can see that right at the back of this we see some NaN over here. These are null values, nothing is in there. So it is telling us that yes, we have some null values in here. Now sometimes let's imagine the null values was in row, let's say 50 or 100, then we are not going to see it over here because it is truncated just around the first 5 rows. So in order to have a proper sense of some of these things, once again, the info method is going to help us. So when I do data.info and run this particular modified iris data set that we have over here, you can see that it shows us the index range, and it's saying that we have 154 entries starting from 0 to 153, which is accurate. Now it says the data columns, as we have over here, is showing us 6 columns, and inside of these 6 columns, when it comes to the ID, it has 154 known now. Remember, we have 154 there, so everything is sorted when it comes to our ID. Now when it comes to sepal length, we are short of 1 because we have 153 instead of 154. When it comes to the sepal width, we have 150. That means we are missing 4 instances where we are missing values for this sepal width. When it comes to petal length, we have 152. That means we are missing 2. When it comes to petal width, we have 147 instead of 154. That means we are missing out 7 over here. And for species, we don't seem to have any problem over here. So clearly with the info method, we kind of have an idea of how some values are missing in our data set. So in order to do this, well, there are a couple of ways of handling this. Let's say you have 1 million data sets and you are just missing, let's say, a particular row, just one value. Well, one value may not harm you so much if you decide to take the entire row out of the equation. So that means you have everything except for that one particular value. It's going to be fine if you are working with any data set of that kind. But then there are instances where you can't take it out, so you need to fix it, and we are going to see that. But for the first time, we are going to look at how we can remove null values using the drop NA method. And this is very simple. Now when I do data sets, once again, we have this NA showing up over here. Now let me create a cell beneath this, and I'll do data sets dot drop NA. So dot drop NA is now going to loop through the data set, if it is 1 million, 2 million, whichever the size, and drop any instance where we have a null value in there. So now when I run this, you can see that everything has been closed up. Okay, now let's take a critical look at the first row we have over here. The first row, we had some kind of a null value over here, so you can see that the index 0 will be dropped, and you can see that this is now starting from index 4, because clearly you can see that for the first row we have none over here, so this was dropped. The second row we have none over here, so this was also dropped. The third row we had none over here, this was dropped. The third row we also had none over here, this was also. So it is actually returning only instances where we have everything filled up over here. Now one of the ways of also checking and knowing is the fact that the original data sets, okay, the modified one, we had 154 rows, but when we dropped, now we are getting 140, because any instance where we have a none or a null value, it will automatically drop it. And that's looking a little bit interesting. So this is it. Now unfortunately, if I'm to come back here and print out data, it is still going to show me what I have over here, okay, even though I dropped it in here. So basically there are a number of ways of handling this. Now the best way to do this is to, for instance, let's say save this in a separate variable. So now when I do x is equal to data.drop NA, anytime I want to print out what I've dropped, and let me print out x over here, it is going to reflect exactly what I have over here. Good. Now let me just clear this and also show you another technique. When I do drop NA, it is going to drop NA, but then when I do data over here, once again, it's going to print out everything in over here. Now if I do drop any and I pass in place and I specify this as true, what then this is going to do is it's going to override the original data sets, and for which reason it is now going to drop all the NA. So now when I do this and run this, we don't seem to have any problem over here. Good. Now when I print out data, first without this it is going to return the none. Now that we have in place is equal to true, now when I run this, you can see that data sets has now dropped all the null values, and now we can use this data set. So it pretty much depends on what you are doing. Sometimes it can be very risky dropping any and passing in place is equal to true. Sometimes it can be very risky depending on what you are doing, but in most cases I would want to save it in a new variable, so that at any point in my analysis, if I would want to bring in the original data set, I still have a copy of it. Good. So now let's go back to what we have over here. So let me just clear this, and now we are going to have, first of all, let me just run this because it is now going to take up the first instance of we dropping any. And in order to do so, let me just do this. So let me just do data is equal to pd.read underscore CSV. I'm importing it once again because drop any is going to override everything. And I'll do iris, capital iris underscore modified dot CSV. So good. Now you have our data over here. And if I'm to print this, I still want to have my any over here. And now if I do any dot drop data dot drop any, and save this in a variable, let's say x. Now x is equal to this, and anytime I want to have a copy of my data set where I've dropped all the null values, I now have it over here. If I want to have a copy of the original data set, I just bring in data set over here, which is the original. The name depends on what you want to do. You can call this original data set something like original underscore data set, and let's say you can call this drop any, okay, from original, depending on whichever name you want to use. Okay, good. But for the purpose of what you are doing, let's just keep it up this way. So now we've dropped any. Now there are instances where we just don't want to drop any, but we would want to replace any. We want to fill any. So over here with our original data set, yes, we still have any or the null values over here. We want to fill it, okay? And in order to fill it, we use the fill any method. So you can see that the names are quite intuitive. Drop any means drop all null values, and fill any means fill all null values. Good. So what then do we have to do? We just have to create a cell over here, and in here I'm going to say data dot fill any, and inside of this parenthesis, what do I want to fill? Let's say I want to fill up with 200, and I'm using 200 because I want it to be very obvious. So you can see that this initially is none. You can see this is none, this is none, and this is none as well. But now when I do fill any 200, let me save this in a variable called y. So now when I run this, we don't seem to have any problem over here. Now let me print out y over here, and you can see that everywhere initially we had none, you can see that it is now being filled up with 200, okay, or 200.0 because it is a float. Good. So you can see that we are now filling up everything. Now if I'm to do something like a y dot info, if I'm to do a y dot info and run this, you can see that now everything has been filled up because we have the index range 154 entries, and everything showing up over here is 154. So now we don't seem to have any problem with null values, and we didn't have to even go into the data to check. We are using the method to do this exploratory analysis. So that's one way of handling this. Now let's say you want to fill null values for specific columns. Okay, so what we did was, picking up 120. So what we did was just picking 200 and filling everything. So the petal width cm was 120, 200, everything was 200 over here. Now what if you want to fill up with a particular value given that particular column? And this is how we go about it. All right, so what we are going to do is we are going to fill any with some specific values for some specific columns. And the way we go about this is very simple. Remember, we already have this data over here which is showing exactly the raw format. And if I'm to run data in here, we see that we have these none values. Good. Now remember what we did in the first video when we were looking at how we can select a particular column. Now we had two ways. So we can do data dot in the name of that particular column. So I'll just copy this and I'll do a Ctrl+C. And anytime you see me copy this, is I click on this and copy it myself, because typing it you may run into errors because you might have typed it wrongly. So when I do data dot what I've copied and do a Ctrl+V over here, I get all the data from this particular column. So now I can select this column this way and assign a particular value, or do a dot fill any with this. Good. Now if I want to select multiple columns, you know what to do. Instead of doing the dots, we then have to use the square bracket. So over here, the most prudent way of handling this is using the square brackets, and we pass this as a string. So when I run this, it's going to return the same value. So now I can do this and a dot fill NA on this particular row, or sorry, on this particular column. So now when I do something like 800, because I want to use a very big value so that things will begin to look different from the original. When I do this, all that I need to do is, for instance, let me just copy this, Ctrl+C, and I'll do a Ctrl+V is equal to this. So I'm grabbing whatever I have in here, and with this particular value, I'm overriding it with this particular dot fill any, and I'm passing 800 in here. So now when I run this, we don't seem to have any problem. Now when I print out data and run this, you can see that everything we have in here with the petal width cm has now been replaced with 800, and it is now leaving the rest of the things we have in here. Good. So if your guess is as good as mine, if you want to do something for, let's say, the petal length, we can just do this. So I'll do a Ctrl+C and a Ctrl+V over here, and I'll just change this to petal length. So I'll do a Ctrl+C over here, change this Ctrl+V, and also change this Ctrl+V. Now what I want to do is, let's use a value, for instance 100. So inside of our new data that we are going to print out, we are going to see that this is going to be still 800, and now this is now going to change to 100 because we are changing every petal length with 100 over here. So I'm going to run this, and now if I run this, clearly we can see that yes, this is still maintaining at 800, and what we have over here is 100. So every instance of the petal length is going to replace it with 100, or every instance where we had a null value is going to replace it, or is going to fill it up with 100. And we can go on and on with the petal width and the petal, the sepal width and the sepal length. Good. But this is just using arbitrary values, and there's even a better way of handling this. And the better way of handling this is to use the mean, the median, or the mode. And this is very important because whenever you have some kind of a data set, regardless of where you got the data set from, these statistical inferences are going to play a big role. So let's say we have, and once again, let me bring out data over here. I should have saved this in another variable, because now if I print out data, it's going to return this for me. Okay. All right. So let me just import data again. So I'll do pd.read_csv, because I want to have it fresh so that we work with it. And I'm going to say iris_modified.csv. So when I run this, and now if I'm to print this out, Control V, sorry, if I'm to print data out, we still have this null values showing up over here. Now, a better way of handling this is to use the mean and the mode and the median and stuff like that. So in order to get the mean, once again, if you want to calculate, let's say, the mean of the petal length in centimeters, all that we need to do is basically to grab this. So let me just copy this and let me create a cell beneath this. Now when I do data dot the petal length, okay, and run this, it's going to return everything I have with petal length over here. Now what I can now do is I can now calculate the mean of this. So I can say mean underscore PL, like the petal length, and this is now going to be equal to what I have over here, Control C and Control V over here, dot mean. So I'll call the mean method in here on this. So what the mean basically does is it's going to calculate the average. So I run this and I don't seem to have any problem over here. So now what I can do is I can now copy this and print this out, and here we have the mean, the average. So it is going to sum up all the values in the this particular entry and divide it by the total number. The total number in this case is I think 154. So it's going to be 1.4 plus 1.4 plus 1.4. In this case, it's going to be 0 plus 1.4, and it's going to divide everything by this. And now we can now replace whichever value which is being lost with this particular mean, and this will make very good statistical sense out of this. So over here, I'm going to show you how you go about with the mean, and with the exercise, we are going to look at it from the median and mode point of view, which is very simple. So over here, yes, we have mean underscore how do you call it, PL over here. Now let me just copy this, Control C, and duplicate this, I think 4 times. And all that I want to do is, the first one is going to be the sepal length CM. So over here, let me just replace this with sepal length CM. So I'm just going to call this SL, sepal length, and it's going to be the data dot the sepal length dot the mean method I want to calculate. And the next one is going to be the sepal width CM, and this is going to be sepal, so SW, sepal width. The next is petal length. So finally, let me go to petal width. So petal length is over here, so let me do petal width, and that's going to be PW, and I'll paste this over here. So this is going to calculate all the means I have in there. Good. And now let me just duplicate this a number of times, or let me just put us in order for this to work, I'll cut this and put this in a print statement, because if I want to print multiple lines, I just have to put this in a print statement. So I'm going to duplicate this a number of times. I should have used a formatted string so that I have some kind of descriptive names attached to this. So let me use a formatted string like this and wrap this up in a curly bracket. And this is going to be like let's do sepal length over here, because that's the first one we have over here. And let me just do a Control C, Control V over here. And the next one is the sepal width, so SW. And once again, this is going to be first of all, let me have this, and let me do this, and let me bring the formatted string over here and do this. All right, so here we are. I think everything is sorted out over here, because we have the sepal length, the sepal width, the petal length, and the petal width all showing up over here. So now when I run this, you can see that this is giving us the mean. Okay, if we want to look at for the median or the mode, it's as simple as doing it this way. So we can also grab and do a dot, and let me just put it out over here because this is actually an exercise and I would want you to look at this. So the mean, this is a mean method. Okay, the mode method is going to be like this, dot mode, and the median method is going to be the median like this. So these are Python methods that we can use to calculate some of these things. So this is very simple, and as you can see over here, I'm just bringing the dot mean. So now that we have this variables in here, we can now do a replace of it. Okay, and that's also going to be very simple. So let's just come back here, and if you have data, remember we still have our null values over here. So what I'm going to do is I'm now going to grab, and I'll put out two brackets over here. So I'll grab this and I'll do a Control V, and this, sorry, this is going to be just one bracket. So this is going to be equal to, then let me just copy this, Control C, Control V, dot fill any. And what do I want to fill it by? I want to fill it up with the mean. Okay, its corresponding mean. All right, then I'll just copy this, Control C, and I'll duplicate this 4 times over here, and I'll just change the values of the others. So the others, the sepal with Control C, Control V, Control V, and the mean SW is what I need over here. Then the next one is the petal length CM. I'll bring this over here, and I'll just change the mean to what I have in here. And finally, the petal width CM. I'll just bring this in here, and I'll change what I have over here to this. Good. So now when I run this, we don't seem to have any problem. Good. And finally, if I'm to do a data or print this out, we clearly have everything being filled out over here, and we are getting these extra decimal places over here because it just had to conform to some kind of padding bits. All right, so this is looking very interesting, and I think it is a very good way of handling this. We can also do a formatting over here where we limit the number of decimal places, but that's also another thing altogether. Okay, very simple to do. So this is just by replacing everything I have over here with this. So now if I'm to do a data dot info, clearly everything is filled up over here because we have 154 known now, and the number of index range we have over here is 154. So this is a better way of handling missing data. If it is just 1 or 2 or 3, yes, you can use the mean. If it is more than that, it depends on exactly what you are doing. You can use the mode or the median. And once again, you just have to do your own research and see what best works for you. Now, to answer the question, which one is good, mean, mode, or median? This is what I will say. It is better. For instance, if you are working with, let's say, building some kind of artificial neural network model or doing some machine learning stuff, what I will say is create 3 different variations of your data sets, okay, for the mean, median, and mode. So you have, let's say, data sets filling null values with mean, data set filling null values with mode, data set filling null values with median, and build 3 independent models out of them. And based on the performances, you'll be able to make informed decisions. Or better still, when you do that, then you can do some kind of analysis of each and every one, because if it is an academic work, you need to make sure that you account for every step of what you do. So that's with this. Now let's look at how we can remove duplicates, because in this particular data set, trust me, there are some duplicates in here. And let me just come back to the very top over here, and let's bring this, because I want us to have the original data sets and work with duplicates. No, I think we can still work with duplicates over here. So let me just call data, and we can see that we can see some few things over here. So with this modified data set I have over here, I've created some duplicates, and see what we have over here on, let's say, row 1 with the index over here, and this 2. Now you have the index repeating, the sepal length repeating, the sepal width repeating, the petal length repeating. In fact, all the values are repeating. Now you can have values repeating and not necessarily imply that it is a duplicate, but in this case, even the index, which is supposed to be a unique thing among them, is repeating. So once the index is repeating, then clearly you should know that there are some issues with your data sets. And in order to remove duplicates, once again, we don't have to go through the data set. If you have 100 rows or 1,000 rows, millions of rows, we can't do that with our eyes. We can just use Pandas, or Pandas is going to help us. So when I do data dot drop underscore duplicate, this method over here, so drop duplicates is going to drop this. But before we even drop duplicates, let's look at this method, which is the duplicated. So when I do something like data dot, let me just leave this over here and come down and create a cell. So when I do data dot duplicated like this and run this, it's going to tell me some few things over here. So, and I wish we can actually see this. Okay, so you can see that the first row, it says false, the second row, it says false, but the third row, it says true, because the third row we have over here is a duplicate of the first row. It is only a duplicate because this already exists, so this is now a duplicate of this, and the other is showing false, false, false. Now we don't have to even look at all of these things. In order to get rid of the duplicates, that's why we have the drop duplicates method over here. So I'll just work with this briefly, and now when I do data dots, and this time around I would want to do drop underscore duplicates and call this method over here. Now when I run this, you can see that something drastic is happening over here. Now we don't seem to have that 1 2 2 as we had over here. Remember, we were getting 1 2 2 in terms of the IDs, but now we have just 1 2 3. Okay, and you can see that the number of rows has also reduced, because initially we were getting 154 rows, but now we only have 150, and this is actually looking like the original data sets. This is actually looking like the original data sets. And once again, the null values has already been replaced. So this is actually a good thing. It's always good to first of all fill null values before checking out on duplicates, because the null values, using the mean or the mode or the median, is going to give you some kind of an average. Then you remove your duplicates, then you can see that you are cleaning data in here. Good. So now let's look at some few things we have over here, and that's with some kind of basic data analysis. Now everything we've done so far has some elements of data analysis in here, because we are getting an insight of our data set. So data analysis basically means getting an insight of data. Now it involves using tools such as Python, which we're already using, and R, which is a statistical programming language, Excel, SQL, and other libraries such as Pandas and NumPy to understand your data sets. Now in this section, we are going to look at the following techniques in data analysis: how we filter, how we sort, and how we get some kind of correlation between data. So the first thing we are going to look at is filtering. So normally what filtering does is we would want to filter. So first of all, let me just put out this data. Okay, and we have this showing up over here, cleaned. We've removed duplicates, and no, we still have the duplicate over here because we, okay, let me just save this in let's say override data this way. So data is equal to this, and now if I print out data, we've removed duplicates. Okay, Good. So now here we go. Now what I want to do is would want to look at this from this angle. We have data and we want to filter. Remember, when we are filtering, that means we are kind of filtering with some kind of criteria. So we want to return the value based on a specific criteria. Okay, so let's say we have males and females. We can say we want to filter the human beings, and the criteria is going to be, let's say, sex or gender. We can also filter human beings, and the criteria can be, let's say, age. So we will normally filter based on a criteria. That means you want to select a few based on a particular criteria. So remember, we used to do something like this. So we'll do data dots, and whenever I do data dots, a name of a column, that means I'm filtering based on this particular name. Okay, now another way of doing this is to do this and data, and in a bracket we do this. If we want to pass in multiple values, we can do so as well. Now a very easy way, and the filter method is very powerful. Let me just show you. So I'll create a cell over here. Now when I do data dots filter, and it takes in a number of attributes over here. So first of all, I can put out items, and the items is going to be a list. So I can pass in, let's say I want to filter by the sepal length. So the items is now going to be sepal length. Now when I run this, you can see that I have sepal length showing up over here. Good. Now if I want to add in, let's say, the sepal width, I can do a Control-C of this and pass it inside of this list. So now you can see that I'm filtering based on this particular criteria, which is the items being passed in the list over here. So that's one way of filtering. Now let's say you want to filter by let's say a particular name, and it depends on the kind of data sets you are working with actually. So we can also filter. So I'll do data dot filter, and inside of this I'm going to pass in a like. And what this like basically does is, let's say I want to filter by some kind of a name. Okay, so let's say I want to filter by a name that sounds like this. So sepal with CM. When I do this, it gives me this. Now what this like does is, it's don't has to be exactly the name. So even if I do petal width, it is still going to work, okay, without the CM. But in this case, if I want to filter by the items, I need to type in the exact name. But if I'm using the like over here, yes, it is like this. Now interestingly, when I do petal and run this, you can see that anything that has petal in there, so anything with a like of petal, filter it and give it out to me. That's essentially what you are trying to do over here. So this is very interesting. And even if I do something like P, anything with a P inside in this particular arrangement, give it to me. And if I'm to do something like, let's say, length, so anything like this, you can see that I now have the sepal length and the petal length. Okay, two kind of distinct part of our data set, and we are just filtering like and passing in a particular string. Good. So that's with filtering. Now we want to do sorting, and what sorting basically does is we would want to sort based on a criteria once again. So let's say we are sorting in ascending order, or we are sorting in descending order, or whichever way that we want to do. So now let's have our data, and this data has no sorting parameter over here. It is just sorting based on, or it is just being printed out for us based on how the original data set looks like. Now when I do data dot sort, and once again, let me just create a cell beneath this so that we have our original data and whatever thing we are doing over here. So when I do data dot sort underscore values, and over here I need to pass in the column in which I want to sort by. Now originally it is kind of going to sort by the ID, okay, because the ID runs from 1 to the last one. But let's say if I want to sort by the sepal length cm. I'll pass in sepal length cm over here, and now when I run this, we seem to have an issue. Okay, when I run this, yes, it has to be in a string. So now look at what is happening over here. It is now sorting by the sepal length. So clearly the indexing would also have to conform to the change over here, and it is sorting in ascending order. So the smallest sepal length is going to show up over here, and the largest sepal length is also going to show up over here. Now what sorting does for you is it can technically show you some kind of outliers within your data set. Clearly it is sorting, and in ascending order you have 4.3, 4.4, and it's ending at, let's say, 7.9. Imagine we have something like 200 in this sepal length cm. Clearly that's an outlier because it is definitely not within the particular range, even though we don't know the range. But then sorting makes it very easy for us to have a better eye view of whatever is happening. So if there was 200 over here, that 200 is going to show up at the very last end over here, and clearly it's going to trigger something that there should be, or there could be something wrong. You can see that same thing happens with our petal length cm. And you can see that the first 5 rows are very small values, and the last 5 rows are very huge value because you are sorting in ascending order. Good. Now we can also sort in descending order, and I think we then need to pass in an attribute ascending, and we'll specify this as false. And now when I run this, we can see that it is now sorting in descending order. So the highest value comes in here and it sorts it out through to the last value over here. So this is sorting by the sepal length. If we are to sort by the petal, the sepal width or the petal length, that's also going to take its form of sorting, which in any case is going to serve the same purpose. But remember, we sort by values and we specify the name of the column, and this is optional whether I want to sort in ascending or descending. Now the last thing we'd want to talk about is correlation. So let's say we have our data over here. This has been cleaned, everything is looking good, and I want to get some correlation between some variables in a data set. We can now do data.cor like this. So this is going to be the correlation method over here, and this is very interesting because you can see that the correlation between our ID, if we compare our ID, the correlation between our ID is 1. This simply means when, or as we go down the line, our ID increases. So there's some kind of linearity, some kind of linear connectivity or connection between our ID. And when it comes to our ID versus our sepal length, you can see that it drops, and we get into the negatives over here. It also drops a little bit, and it also drops a little bit over here. So as our ID increases, this one gets negative and this one drops a little bit. Good. Now we can also see that when we look at the attribute against the attribute, definitely the correlation is going to be 1. Okay, the attribute against itself, the correlation is going to be 1. So over here you can see that the ID is 1. The sepal length against the sepal length, you can see it's 1 over here. The sepal width against the sepal width is 1 over here. The petal length against itself is 1 over here, and the petal width against itself is 1 over here. What is of prime importance is, for instance, let's say the petal length and the petal, the petal width and the petal length, and this is getting closer to 1. So that means there's no wide variance between these two. Okay, there's no wide variance, but you can see that there's a wide variance between the petal width and the sepal width. So clearly different flowers will have different, completely different petal width, and this is of prime importance to every analysis you may be working with. All right, and you can also see that the petal length, in terms of petal length, is pretty much, the petal length in terms of petal width is pretty much okay with different flowers. But then when it comes to the width, so clearly you can see that the wide variance is between the width, okay, the petal width and the sepal width. and you can see that everything over here is showing up negative over here when you compare to what we have over here. So this is going to be the end of this video, and in fact there's more we can do with pandas, but basically this is most of the things you are ever going to work with using pandas. Any other examples of other machine learning tutorials that I'll be releasing in the coming days, you definitely see some of these things come along, and also other functionalities or methods or skill we can use in our data analysis. Now, if you find value out of this video, I'm most grateful. I like the support that I'm getting, and I'll kindly encourage you to subscribe to my channel, and don't forget to hit on the notification button so that anytime I release a video, you'll be duly notified. Also, share this video with friends and family who find this content very useful. At Cambridge Tech, we say learn programming. You can do it, and catch you in the next video. Bye bye.